Hi everyone, and thank you for joining our presentation on Surfworld. The inspiration for this web-based application came from my Hawaiian surfing days. I frequently wanted to know information coupled with my favorite surf spots, and there wasn't a resource out there that fit my exact needs. I'm going to let Matt just dive right into our backend architecture.
So the value our application provides lies with our surf-specific data, so I'll begin here. We use Surfline API to curate a list of 5,000 plus targeted beaches, which we end up storing in Dynamo. For each of those beaches, we will then query Yelp in order to source lessons, shops, and restaurants that are nearby to that geolocation. Now, from a backend perspective, LF1 search is the core of our functionality. We are able to search for beaches, shops, and lessons in a variety of manners, which will be covered later. It'll communicate with LF3 in order to turn location strings into geo coordinates. LF7 will manage our profile data. LF2, LF5, and LF4 calculates our secret sauce that uses Weather API and Surfline data, which we'll delve into later. LF6 and LF8 manages emailing the detailed data that you like to yourself at a later time. And lastly, LF9 is a get favorite interaction, which will return favorite beaches tied to a specific profile.
So some details about the backend design and scalability. So from a compute perspective, we use Lambda and API Gateway to provide connectivity between the backend and the front end. From a storage perspective, we use DynamoDB for key value storage for schema list data that's ultra fast access. We use OpenSearch for efficient search. We use RDS for location data. Having the structure of schemas helped us solve some integration issues we were having. And we use S3 as a blob store to store user profile images and also for the front end code. Also to take some load time off of the page, we periodically refresh surf score using CloudWatch trigger events so that happens asynchronously in the backend and not when the page is loaded. I'm now going to hand it off to Nana to talk about the front end.
Great. So our front end was designed with React to allow for quick responsiveness and also for quick scalability with addition of new components. Our site is deployed to an S3 bucket via code pipeline and also code build. Our website is distributed via CloudFront to allow for quick browsing on our website. Also, our users are verified via Google authentication services.
Here's the first page that the users see. Users can input a beach name or a location and press search to go into the results page for beach breaks, lessons, and shops.
So our search results page allows users to view results in two different ways. So on the left, we have user cards where users can see the results, and then also on the right, users can also see the results on a map. When user clicks on a card, it takes users to a details page, which Ethan is going to talk about next.
So I'd like to draw your attention here to the surf score in the upper left-hand corner. Now, most surf-based applications provide a rating based solely on the conditions of the wave, but we decided to take in some other considerations along with the surf conditions. We specifically added weather, nearby restaurants, nearby shops, and nearby lessons. We believe this provides a more holistic experience score.
In the future, we would like to add the ability for users to interact with each other with comments and reviews. We would like to add multi-region deployments, would like to add a mobile app for a more convenient user experience, and improve our backend query performance to send us faster results.